We are going to solve the solved example based on the practice set 1.4, page number 25. Here, three solved examples are there, and all three solved examples are based on the theorem of areas of similar triangles. The theorem of areas of similar triangles says that when two triangles are similar to each other, then the ratio of the areas of those two triangles is always equal to the ratio of the squares of their corresponding sides. As per solved example, question number 1, triangle ABC and triangle PQR are similar to each other. Let's assume triangle ABC and triangle PQR, which are similar to each other. The area of triangle ABC is given as 16 units and that of triangle PQR is given as 25 units. Now we have to find the value of AB is to PQ. Now if you look at the figure, you will find that AB and PQ are the corresponding sides. It means now as per given, if they say that triangle ABC and triangle PQR are similar to each other, this is our given, then by the theorem of areas of similar triangles, we can say that the ratio of the areas of those two triangles is equal to the square of both the corresponding sides, AB square and PQ square. Now the ratio of AB square and PQ square will be considered for both the triangles. Here, as per given, ABC is 16 units, this is the area, and the area of triangle PQR is 25 units, which we will substitute here. Means 16 is to 25 is equal to AB square is to PQ square. But we don't want the squares, we want just AB is to PQ. So if we consider the square roots of both the sides, AB is to PQ will be equals to the square root of 16 is to 25. 16 and 25 both are the perfect squares. 16 has square root 4 and that of 25 is 5. It means the ratio of AB and PQ is equal to 4 is to 5. The question number 2 is ratio of corresponding sides of two similar triangles is 2 is to 5. If the area of the small triangle is 64 square centimeter, then what is the area of the bigger triangle? Assuming that these two are the triangles where PQR is the bigger triangle and ABC is the smaller triangle. Here they have given the area of the smaller triangle, that is 64 centimeter squares, and the ratio of the corresponding sides of both the triangles is 2 is to 5. In ratio 2 is to 5, you will find that 2 is smaller than 5. It means while taking the ratio, we are considering the smaller triangle first. Means AB is to PQ is considered, not PQ is to AB. We need to note it. Now AB is to PQ can be considered as 2 is to 5. We have to find the area of the bigger triangle. Now by the assumption our bigger triangle is triangle PQR, we can write it that considering triangle PQR as bigger triangle and triangle ABC as the smaller one, we know the theorem of areas of two similar triangles tells us that the ratio of those two triangles is always equal to the ratio of their squares or their corresponding sides. Now here, area of triangle ABC and area of triangle PQR will be equals to AB square upon PQ square. But AB is 2 units whereas 5 is the value of PQ. While substituting these two, and the area of triangle ABC is also given, that is 64 square centimeters, we will substitute that. When we solve this, 64 upon area of triangle PQR equals to 4 is to 25 by squaring 2 and 5. The square of 2 is 4 and that of 5 is 25. When we cross multiply, we will get area of triangle PQR equals to 64 multiplied by 25 and 4 will divide. If we solve this, we will get the area of triangle PQR as 400 centimeter square. So finally we will write the answer. Area of the bigger triangle is 400 centimeter square. In example 3, ABCD, quadrilateral ABCD is a trapezium. two sides AB and CD are parallel. We'll assume this figure ABCD is a trapezium where side AB and DC or CD are the parallel sides. Then diagonals AC and BD intersect at point P. Now we have to prove that the ratio of areas of triangle ABP and CPD. ABP means this upper triangle and CPD means this lower triangle. If we consider these two triangles, and we have to prove that the areas of both these triangles, their ratios are equal to AB square and CD square. Now, in proof, we will consider these two important things. Quadrilateral ABCD is a trapezium. As this is a trapezium, ABCD parallel sides. Now, we will consider side AC as the transversal. We will consider here taking segment AC as a transversal. As AB, CD are parallel, AC is the transversal, angle PAB means this one and angle PCD means this one are congruent to each other because they are the alternate angles. So we will write them. Similarly, we will consider these two angles. Angle APB and angle CPD. These two are congruent because they are the vertically opposite angles. So if two pairs of corresponding angles are congruent to each other, triangle ABP and triangle CPD, triangle 1, triangle 2 are similar to each other by angle test. And if two triangles are similar to each other, we know that the ratio of their areas is equal to the squares and their ratios. Means triangle ABP upon triangle CPD is equal to AB square upon CD square by the theorem of areas of similar triangles, which we had to prove.